Well, hello guys, here Mr. G with another video. This time we're going to be starting to answer the mid-year diagnostic exam developed by Professor Rodriguez in 2023 for the learners at the Northern Cape. And we're going to start with question 1. We're going to answer all the questions in different videos, and we're going to start with question 1, which is the multiple choice. So the question 1 is a multiple choice, and this, guys, is very important because it have 20 marks. So it is a very important question. It have a lot of marks in the exam, and each sub question is either 2 or nothing, so you cannot get 1, or let's say something like that. Now starting here, the first question says, which one of the following terms describe hydrocarbons that contain only single bond? And guys, the answer is saturated. You should know that the hydrocarbons that have single bonds are called saturated hydrocarbon. It's a straightforward definition. Question 1.2. This is a 1.2 question there. It's a problem with the numbering. A renewable source of energy that can be produced by the fermentation of the sugar in sugar cane or corns is ethanol, and this is also something you should learn by heart. There is not much to do. You know that this is a renewable source of energy and is coming from the fermentation of sugar cane. So the ethanol is coming from sugar cane. 1.3, remember this is a numbering problem here. This is 1.3. Consider the reaction represented below, and then you have that chemical reaction there. Then the term that best describes this reaction is, and then you have elimination, addition, cracking, or polymerization. Guys, this is cracking, in which that specific hydrocarbon there is broken into smaller one. That is cracking. Question 1.4. This is 1.4. Remember, problem with the numbering. Which one of the following alcohols given below has the strongest intermolecular forces? You have methanol, ethanol, propan-1-ol, and butanol, and it is very simple. You are increasing the number of carbons, so you are increasing the surface area. Therefore, the correct answer is D, which have 4 carbons. You're starting with 1 carbon, guys. I'm going to do OH here just for you to see. Ethanol will have 2 carbons. The OH, let's do it here. This is just for you to note the propan-1-ol. This is the OH. The propan-1-ol will be 3 carbons, 1, 2, and 3 carbons. You can see that the surface area is increasing, the molecule become larger, and the butan-1-ol will be now 4 carbon. So the longer it comes, the greater the surface area is, and therefore the stronger the intermolecular forces, and the higher the boiling point. Which one of the following will have the stronger intermolecular force? That is D. Question 1.4. N2O2 is placed in a seal. This one will be question 1.5 in actual fact. 5, remember there is a numbering problem. N2O2 gas is placed in a sealed container. After a while, the following reaction takes place in the container at constant temperature, and you can see what there is that specific reaction. Which one of the following graph correctly illustrates the relationship between the nitrogen dioxide concentration and time? So you have the concentration of nitrogen dioxide, and you have time in the x-axis, and you have the 4 options there, the 4 graph. Okay, now what is going to happen to the nitrogen dioxide there? As time passes, guys, the reaction is going to decrease the rate of the reaction. The concentration is going to decrease, or let's say stop. The rate at which is formed is going to stop up until then the reaction is at equilibrium. In this point, the correct graph will be C. It's a quite simple graph. You're going to work with this graph a lot, okay? And it's the formation of NO2, which is the case here. All right. Okay, so question 1.6, consider the following reaction taking place in an open vessel at certain temperature. And you have the reaction, which is delta H is negative. Is not part of the question, but remember, just in case delta H negative means that the reaction is exothermic. The initial reaction rate of the above reaction may be decreased. They want to decrease the rate of the reaction. And now that is important. Adding a catalyst, well, you cannot add a catalyst and decrease the rate of the reaction. At least it's a negative catalyst. This catalyst is to increase the rate of the reaction. Cooling the system, well guys, there is the answer. Nothing else to say. If you cool the system, you decreasing the temperature, the reaction rate decreases. Okay? Question 1.7. Consider the following equilibrium. And then you have a chemical reaction in which also delta H once more is negative, which means this one is an exothermic reaction. Okay? Which one of the following will favor the forward reaction? So they want to favor the forward reaction. Let's see how can we favor the forward reaction. Increase the concentration of I2, guys, that is the answer. It's not much to say. If you increase the concentration of either reactants, then the forward reaction will be favored. That is quite simple. The other way is to decrease the concentration of the product. Now they say increasing the temperature. No, because it's an exothermic reaction. Exothermic reaction is favored when the temperature decreases. So exothermic will be affected if the temperature decreases. Alright? Remove H2. No, if you remove any of the concentration of the reactant, the reverse reaction will be favored. And adding a concentrated HI solution, that one will favor the reverse reaction. Guys, nothing to say. The answer is A. It's a quite simple question. This one is 1.8. Remember, it's a 1.8. Professor had a small problem there with the numbering. A hypothetical reaction reaches equilibrium at 10 degrees Celsius in a closed container according to the following valence equation. And then you have a valence equation there, which is a hypothetical. Once more, they say delta H is negative. It means the reaction is exothermic. Alright? I don't know if we're going to use it or not, but I always like to say what type of reaction is the one we're working with. The temperature is now increased. So if they increase the temperature and this reaction is exothermic, it means that the reverse reaction is going to be favored, because remember, we just say it here, a decrease in temperature will favor the exothermic. Okay, so now if you increase in temperature, the reverse reaction is going to be favored according to what they say here. You increase the temperature, therefore reverse reaction is going to increase. Guys, I didn't even read what is going on yet, but we know that. We are analyzing the problem. Which one of the following is correct as a reaction approaches to the new equilibrium? Reaction rate increases. Well, when you increase the temperature, it doesn't mean that it's going to be favoring the Bauer reaction. All the reaction is going to increase in rate. So it's going to be either A, B, or C, because the reaction rate is going to increase if you increase the temperature. Alright? Now, the yield is the one that changed. We said the Bauer reaction or the reverse reaction is going to be favored. Therefore, more A and B will be at the end. So now they say here yield of product is going to decrease because the reverse reaction is favored. Therefore, the correct answer is B. I hope you understand. This one is a quite interesting question. Question 1.9. 1.9, remember the problem with the numbering. I think there is an extra question because there was a confusion with the problem, but it doesn't matter. It's very good for us to practice. Refer to the following equation and you have one equation there. The two Bronsted-Lowry base in the reaction equations are. And for this one, all you have to do is to identify the acid and the base. So let's look for the families. This one is going with that one, and this one is going with that one. Those are the families, and there is a video on identifying acid and bases. So if we go to the NH3, which is ammonia, and it's going there, you can see that one hydrogen was taken. So this is a base, but you should know that ammonia is a base. All right, and therefore this one is a conjugate acid. All right, now the H2O in this reaction here, what is happening from reactants to product? I'm going to do it here so you can see it. One hydrogen is gone, so this one is the acid, and therefore the OH minus is the conjugate base. Okay, that is the answer. Now they say which one is the two bases. So it is going to be the NH3 and the OH. So it's NH3 and OH. The answer is C. Also a very good question. Which one of the following substance is or are amphiprotic? And there's also a video on this topic, guys. I leave the link, you can go and watch it. And there is only 2 amphiprotics here. This one because it can either donate an extra proton, but because it's a ion, it can actually accept also a proton. And the other one is going to be substance 3, which in the same situation here, it can donate that hydrogen that still have there, but can also accept another hydrogen. So in this case, the answer will be 1 and 3. It's quite simple. It's a very good question. And question 1.11, a small quantity of concentrated hydrochloric acid is gradually added to 1 cubic decimeter of distilled water at 25 degrees. After testing the result solution, it is found that the value of the Kw, and they give you different options there. This question, once more, we are going to leave it open for learners that watch the whole video, answer this question in the comments below. But thank you for watching, guys. This is a good multiple choice, which a gifted extra question. So thanks to Professor. Next time we'll go to do question 2. Thank you for watching. Subscribe for the channel. Sum up. I'll see you next time. Mr. G here.